Hi guys. So what you guys been doing for the past 2 weeks is adding and subtracting, multiplying and dividing rational expression. And the purpose of those things are for you to solve rational equation. So today I'm going to show you, and we're going to discuss the method of solving rational equation. Okay, so let's get started. So I'm going to use this color. Alright, solving rational equation. Okay, this is just another type of equation. You guys already learned how to solve linear equation. Linear equation is the equation that contains x variable in linear form, and rational equation is the equation contain variable x under denominator. This is not rational equation. It's not fractional equation, okay? Because sometimes you see the fraction, but it's still linear. Okay, but for rational equation, in order for equation to be rational equation, variable x must be under denominator. If the variable x is on the numerator only, it's still linear, even though you see the fraction over there. Okay, but if you see variable x under denominator, then you can guarantee that it is rational equation. For example, something like this. So before I jump to the example, I think I'm gonna give you a general tactic, a general strategy of how to solve rational equation. Okay, general strategy. Maybe some of you doesn't want to follow my tactic, my strategy, and you can come up with your own way of solving rational equation. That's fine, but I just assume that you really new to this, so I recommend that you guys should follow all of this step, and I'm sure that when you guys follow all of this step here, you can solve any rational equation. So the first thing you have to do, the first step you have to do is you have to factor all denominator. Okay, as much as possible. Okay, so after you factor all denominator, you remember it is kind of the same when you try to multiply or dividing rational expression. You have to factor everything out. Okay, then after you factor all the denominator, you find LCD. Okay, you find LCD. Then after you find LCD, you try to bring equation. Okay, bring equation to proportion form. Okay, what proportion form? Maybe some of you still remember. In order to solve proportion, you try to do cross multiply, right? So the proportion, it will be in this form: A over C equal B over C on both sides. Then the last step is to set A equal B and solve for variable x. There you go. So this is the general strategy of solving the rational equation. Try to follow this. Okay, I mean, maybe if you get a tutor and the tutor come up with another method, that's okay if you feel comfortable with that method. But what if you cannot afford a tutor and you just follow what I'm saying? So try to strictly follow all the steps here. I'm sure you can solve any rational equation. And the second thing before we jump to our first example is that there's a requirement for an equation to be rational equation. So first of all, this is that variable must be in denominator. Okay, must be in the denominator part. Okay. The second condition is that of course it must be in rational form. So the term must be in rational form. Okay. There's only they only need two conditions here for the equation to be called rational equation. Okay, because after you simplify everything out, you try to bring it to proportion, sometimes your final equation is quadratic, sometimes it's linear. Okay, but initial condition for equation to be a rational equation, it must be this. Okay, it must be this. Now let's jump to our first example here. Example number 1. Let's see, I can use a different color. How about, let me use well, I just use white colors. Example number 1. Let me start with a very simple rational equation first, and try to recognize if this one is really a rational equation or not. So we have equation like this. So 2x, okay, minus 3 over 2 equal 7 over 2. Okay. Alright, so try to follow all the steps strictly. Okay, so first of all, this is a rational equation because you see that all the term in fractional form. Okay, the term must be in fractional form, must be rational form, and you see the variable x under the denominator. I mean, you probably can see a variable x on the top, but a variable x being on the top is not a condition. It's not a requirement. The variable x must be under the denominator for the equation to be a rational equation. Okay, so let's see how we're gonna solve this if we try to follow all the steps here. So you see that the first step we're gonna factor all the denominator out. So it looks like that all the denominator has been in factor form. There's nothing we can do anything. So the second step is try to find LCD. Try to find LCD. So try to find LCD for all of them. Okay, for all the term here. So the LCD over here, because this is x, it is 2, and this is x, it is 2. So LCD will be, you're gonna take all the different factor, which is in this case will be 2x. Okay, so now let's compare it. So they're missing number 2, so you're gonna multiply the top and the bottom by 2. And over here you're missing x, so you multiply the top and the bottom by x. And over here you're not missing anything, so you just go ahead and keep it. Okay. Alright, so after you find the LCD, try to multiply them. So this implies 2 times 2 is 4 over 2x minus 3x over 2x equals 7 over 2x. Okay. And now what we see? We see that these two fractions here have the same denominator, so it means we can combine them over 2x. And you see that we just successfully convert into proportion form with C and C the same, right? Denominator the same. And now we just need to set the numerator A and B. So it's A and B, and you go ahead and set this. Okay, you set this equal each other. Okay, So 4 minus 3x equals 7. So this implies 3x equal to 11. Is that 11? No, it's not 11. Equal to negative 3. Then x equal to negative 1, right? Okay. And this will be your solution, but you don't know this is the extraneous solution or not, so you gotta go ahead and plug them back in here to check if is this correct answer or not. So you look over here, you will see that you have negative 7 over 2, negative here. Yes, so this is the correct answer. No matter what type of equation you solve, you gotta do the last step, which is the checking step. Okay. So this will be your answer. Okay. So you see that I try to follow all the steps strictly. Okay. Example number 2. This one here, you see in the first example, you don't have to factor anything. But now let's take a look at this one. I have 2 over x minus 3 minus 3 over x plus 3 equal 12 minus x squared minus 9. Alright, so you see the denominator here. This is rational equation because it's a variable x in the denominator, and you see x minus 3 you cannot factor anything, x plus 3 you cannot factor any. And however, this one you can factor, right? This is a different of square, so go ahead and factor them. Factor them. So they become 12 x plus 3 x minus 3. Okay. Alright. Alright. And now you see that we have to find LCD. So LCD, we're going to take all different factors. So you have x plus 3, x minus 3. So this is repeated, so you just need to take one. And now we compare the LCD with the denominator. You see that over here they're missing the x plus 3. So you multiply the top and the bottom by x plus 3. And over here you multiply the top and the bottom by x minus 3 because they're missing the x minus 3. And over here you don't have to multiply the top and the bottom because they are the same, because they're not missing anything. So x plus 3, x minus 3. Okay. And now you see that this is the same denominator. We can go ahead and combine them. So go ahead and combine them. So you have 2x plus 6, right? Distribute the minus 3 in, so negative 3x plus 9 over x minus 3, x plus 3 equal. So you try to, you see that I'm trying to convert it into proportion form. There you go. And now what happened here? I see that I have a proportion with the same denominator. So over here we have negative x 6 plus 9 15 over plus 3 equal 12 equal x plus 3 x minus 3. Excuse me. And now we can set the numerator together. So negative x plus 15 equal 12. So negative x equal negative 3 and x equal 3. Now let's check. You see that when x equal 3, you plug it in here. 3 minus 3 is 0. So 2 divided by 0 doesn't work. So this is extraneous. It's extraneous. It means that this is no solution. Okay. You always have to check, of course. If you don't check, then you see that if you take x equal 3 as the final solution, then everything will be wrong, right? Everything will be wrong. Alright. Okay. So that's the second example. Okay. Now let's start with our third example. Okay, I have example number 4 like this. Example number 3, I mean. I have 3 over p square plus p minus 2 minus 1 over p squared minus 1 equals 7 over 2 p squared plus 3p plus 2. Alright. Now what do we see over here? What you see is that we have two trinomial. It might be factorable. So we gotta check if it is factorable or not before we can do LCD. So over here 3. Alright, go ahead, try to factor that. Let's see what happened here. So we have p plus 2, p minus 1. Okay. And this one is different of square, so this is p minus 1, p plus 1. And this one is also a trinomial, so we have p plus 1, p plus 2. Okay, so right now you can get LCD. Now let's take all the different factors. So you have p plus 2, you have p plus 2, so you just need to take one time. P plus 1, you take one time. P minus 1, you take 1. P plus 2. Alright. You think what I'm missing? Oh, I'm missing number 2. There you go. So that is your LCD. Now, so you see that if you compare this with your the denominator, you see that they're missing they're missing 2p plus 1, right? So they're missing 2p plus 1. Okay, so let's see. So, oops, I don't know what it looks like now. So I have to multiply on the top and the bottom by 2p plus 1. So we're gonna have 3p plus 1. Okay, so we have 3p plus 1, 2p plus 1, p minus 1, and p plus 2. Alright, now let's go back. And then the second fraction they're missing 2p plus 2. Okay, they're missing 2p plus 2. So here will be 2p plus 2. I don't know, is that addition or is it subtraction? 2p plus 1, p minus 1, p plus 2. Okay, and for the last fraction, they're missing p minus 1. Okay, they're missing p minus 1, so I'm going to multiply the top and the bottom by p minus 1. Okay, there you go. Now you see that we have fraction. Three rational expression here with the same denominator. So I can keep the denominator, which is 2p plus 1, p minus 1, p plus 2, and on the top I have 3p plus 3 minus 2p minus 4. I distribute the minus in, equal. I distribute this 7p minus 7 over 2p plus 1, p minus 1, p plus 2. And now you see that we have two fractions with the same denominator. This is proportion. Then we can set the numerator together. So we're going to set 3p plus p minus 2p minus 4 equal 7p minus 7. So you see that I'm trying to follow my old strategy really strictly. So I have p minus 1 equals 7p minus 7. So 7p minus 7 could be 6p equal, at most side by side, 6, so p equal 1. And I don't know if I got anything wrong over here. I think there's something wrong, right? Because I should multiply over here by 2 on the top also, because this 3 already, they're missing, so there should be 6 right here. So I multiply over here by 2, so it should be 6p. See, so this is 6p plus 6. 6p plus 6. So 6p minus 2p should be, so this is 6p. Okay, 6p plus 6. Let me write this. Okay, 6p minus 2p is 4p. And this is give you plus 2. Okay. Now what we have over here? We have 7p minus 4p give you 3p. And this is give you 9. See? Then your p will be 3. And if your p is 3, if you go ahead and plug it in, you see that it satisfies the equation. So this will be your final solution. Okay. Make sure that you gotta plug in. Okay. I'm not doing the checking part because checking part is your own job. Okay. You gotta do it yourself. Whenever you solve the equation, you gotta do your checking. Okay. Excuse me. Now let's do another one. I try to do as many examples as I can so that you guys can understand, because they just need to change the form. Then some of you have trouble with it. Alright, how about this one right here? How about this one right here? This interesting one right here. I have 3 over x squared plus x minus 1 over x plus 5 equal 2 over x minus 7. Alright, so first job we could have to factor, and then one of the priority of factor is finding GCF. So we got 5 GCF here. Think about GCF first. GCF, GCF, GCF. Okay. And your LCD here will be what? You're gonna take all of them. So we have x plus 1, x plus 5, x minus 7. They all different. So LCD will be everything. X plus 1, x plus 5, x minus 7. Okay. So now let's compare it. You see that over here they're missing the x plus 5, x minus 7, right? So you multiply by x plus 5, x minus 7 on the top. And the bottom is x plus 1, x plus 5, x minus 7 minus 1 over. And over here we have they're missing they're missing a lot of things, right? They're missing x, they're missing x plus 1 and x minus 7. So at the bottom they already have x plus 5, so you just need to multiply by that. So you have x plus 1, x plus 5, x minus 7. And over here they're missing 3 terms, so you have 2x, x plus 1, x plus 5, you need to multiply by. And the bottom is x plus 1, x plus 5, x minus 7. There you go. Now you see that when you distribute over here, we have quadratic, so you gotta be careful with that. So we have x plus 1, x plus 5, x minus 7. Over here also have x plus 1, x plus 5, x minus 7. Okay. Alright, so let's distribute this. So I'm going to do carefully. I'm going to distribute all the x first. So we have x squared minus 2x minus 35. Okay. Alright, minus x, and distribute this, which is x squared minus 6x minus 7. I'm sorry guys, I have a very bad allergy. I have 2x, and over here I have x squared plus 6x plus 5. Alright. Now you see that this is the same denominator already. You can go ahead and throw away the denominator. Now I can go ahead and distribute number 3 in. Oh, 35 times 3 is 105. Let's give you negative x to the third. Okay. It's a pretty big number. Plus 6x squared plus 7x equal 2x to the third. Alright. I think, let's see, I just want to check if I'm missing anything. Alright, so we have 12x squared plus 10x. There you go. So let's combine like term right here. I have 3x squared, give you negative x to the third plus 9x squared. Okay. Let's check one more time. 9x squared plus x, right? Minus 105. Okay, equal. Okay, equal. Over here, there's nothing to combine, so I just rewrite it. That's 12x squared plus 10x. There you go. Okay. So what we have left is over here is let's combine that term right here. Give you two. Let's see. You will have 3x to the third. 3x to the third. Right. You have trackers give you 3x squared. Okay. Plus 9x minus 1 plus 105 equals 0. Alright. So what is the problem right here? The problem right here is that after we bring it to proportion form and see that we find LCD and stuff, and it turned out to be that we have a quadratic. And this quadratic here, that's a big number, 105. So there's no way that you can solve this. So if you stop it right here, I mean, I don't see the point. I'm going to show you how to I've shown you how to solve this, because this is quadratic. This is a cubic equation. This you gotta use some tactics, very special tactics to solve this. So if you stop right over here, it will be great. Okay, I don't need you to keep going, because this is, it turned out to be a cubic equation. I don't know, for some reason, some way, somehow, the equation is it turned out to be a cubic one. Some way, somehow, this is not a good equation at all, right? But it still have solution. It still has solution. It's just because the solution is just a solution of a cubic equation. All right. All right. So let's see. We can do another one. Let's see. We're gonna do another example number 5. For some reason. Okay. on this example, I will give you something simpler, something pretty short for you to do. Okay, so I have something like this. I have 5 over n plus 4 over 6 minus 3n equal 2 over 6 minus 3n. Alright. So first of all, again, we gotta factor everything out. So we gotta find G-shape here. So G-shape is 3, 2 minus n. Same thing here. We have 3, 2 minus n. And we see that the LCD will be take on different ones. So we have 3, we have n, we have 2 minus n. Okay. Finding LCD is very important, because if you got a wrong LCD, everything will be wrong. Because you will multiply the top and the bottom the wrong one. So you must be able to find LCD. Okay. So let's compare, because you see that if you got LCD wrong, when you compare it wrong, everything wrong. So they have n, right, but they don't have the 3. So we'll give you 3 times 5, 15. 2 minus n. In the bottom we have 3n, 2 minus n. Plus, they have 3, they have 2 minus, they don't have n. So you multiply the top and the bottom by n. So we have 3n, 2 minus n. And over here, they don't have the n. So they don't have the n. So multiply the top and the bottom by n. So we have 3n, 2 minus. So you see that after I multiply the top and the bottom by some missing parts, so I see that I can go ahead and combine them together, because all denominator are the same already. So I have 30 distributed by 15n plus 14 plus 4n, sorry, equal to n over 3n, 2 minus n. Now this proportion had the same denominator, so I can go ahead and set the numerator to equal each other. Okay, so this which is give you negative 11n equal to n. Alright. So what we have over here, I see that let me see. I see that we have we're gonna have, and we have linear, so we give you 11, so we have 13n equal 30. So n equal 30 over 11, and that will be your final answer. Alright. It's not a good solution at all, because see that we have a fraction, and this fraction is not really nice. I don't know if I have any careless mistake during the process, but I don't think so. I mean, it's just the answer, the final answer is not nice at all. And again, because it's not nice, so it's very hard for you to check. But you still can check it, and I'm not checking for you. Okay, you can go ahead and do it for yourself. Let me check one more time if it's got an LCD correct or not. Oh yeah, it should be. It should be. All right. So in this example number 5 here, we have to find G-shape. So whatever you learned in the past, right? Whatever you learned in the past, you learn factor by G-shape, factor by trinomial, using the difference of square, okay, difference of cube. All of them can be applied in solving rational equation. All of them can be applied when you add and subtract. You see that you have adding over here. That's why they put factoring first. You are supposed to learn factoring first, then you're supposed to learn adding, subtracting, multiplying, dividing. Then finally you learn how to solve a rational equation. Okay. So I'm gonna stop the video, the lecture video today. It is a pretty short one, and you see that all the concept, you see that all the problem, you're gonna repeat the same process. Everything will be the same. All you have to do is you go ahead and practice for yourself, and you have to practice how to find LCD. As long as you can find LCD, then you know what part you should, which one you multiply the top and the bottom, then I'm sure that you can convert to the proportion, and you can set up the numerator together. I'm gonna use different color here to circle the numerator. So the numerator right here, you set up equal to each other is this and this. You see that right here? Okay. Because the denominator is the same already, that's why you can set up the numerator together. Okay, don't try to cross it, because some of the tutor they probably want you to cross this. I'm not going to say the crossing is wrong, but it doesn't make sense, because you have the denominator and you go ahead and cross them, and I mean it's not a good idea, because you cannot just go ahead and cross the denominator, you know. So it makes more sense if you set the numerator together. Okay. Alright, so I'm gonna start the video today right now, and let me know if you have any question or concern. Okay, send me a message through Canvas. I'll see you next time.